Hey guys, so let's do the practice test problems that you didn't have to do on the last test for graphing. This would be the ones where you're solving the absolute value inequalities. So if you look at number 3, um, it's going back to solving. So just to kind of refresh your memory, you've got -6 times the absolute value of minus 2 equals -20. All right. So I'm just going to leave that there. I'm not going to rewrite it. I'm just going to say, okay, what am I going to do to both sides? I'm going to, I've got the next, I got to get rid of the -6 and the -2 so that I have the absolute value all by itself. So you're going to do, you always add or subtract first. So I'm going to do +2 here on both sides. And so that gives me, I thought I was going to have a skinnier line here. All right, so that is going to give, oh, this is the one I wanted. All right, so now I've got, so this will go away, right? And so now I've got -6 times the absolute value of x plus 3, right? That went away because -2 plus 2 is 0 equals, and then -20 plus 2 is going to be -18. So now I have -6 times the absolute value. So the inverse of that is divided by. So I'm going to divide both sides by -6. So now that goes away, right? And I have the absolute value of x plus 3 equals, and then negative divided by negative would be +3. All right, now I guess I have to make that for each one. All right, so now I've got my absolute value by itself. It's equals, so I'm going to have two equations that I write down. I'm going to write x plus 3 can equal -3, or x plus 3 can equal +3. Either way, that will give me 3, all right, because absolute value makes everything positive. And then I just go ahead and solve, and I'm probably going to have to do this again. Then I'm going to do -3, that goes away, and I get x equals -6. And then I'll do -3, and then I'll get x equals negative, that would be 0, right? 3 minus 3 is 0. So my set notation is going to be x such that x equals -6 or 0. All right, that's the set notation. And then interval notation is where you just say, okay, they are -6 and 0 are my two answers there, the two intervals. And the rest, we have done this on our test, so we don't need to do that. Actually, this last one didn't have this one. So if I'm looking at this problem right here, all right, it's not a function because it's doesn't pass the vertical line test, right? The vertical line crosses twice, all right? That's why it's a domain and range of this relation, okay? So I want the domain, so that's x values. So it goes forever to the left, right? So it goes to -infinity here, and it stops going at 5 when x is equal to 5. And that's why I have this, because that is actually part of this function here. But the -infinity would be parentheses. So it goes from domain, it goes left to right, so -infinity to 5. That is my domain. Domain is the x values, and you go left to right. All right, left to right. And then now for the y values, the range, you're going to go bottom to top. So now what people always want to say is they want to choose these y-intercepts. That's not what you're looking for. You're looking at the end. It goes down forever, and it goes up forever. So the range would be negative infinity to positive infinity. And then now I've got these transformations that we did together in class. And now we're doing these graphical characteristics. All right, so my parent function, well, I see it's that V shape, so I know it's an absolute value, right? Equals the absolute value of x. That's my parent function. And then now the domain, I'm going to go left to right. Well, it goes forever to the left, so that would be negative infinity, and it goes forever to the right, so it goes to positive infinity. Range is bottom to top. Well, it goes down forever, so that's negative infinity. The top point is this maximum right here, and so the y value here would be 1. So negative infinity to 1. Oh, but it includes that 1, right? Because that 1 is actually on the graph, so I'll use a square bracket. All right, now intervals are going to be x values and where it's increasing. So I'm going to look at where my function is increasing. So as I go left to right, it's going up. So this is the increasing side, where my function is increasing. Well, what are the x values where it's increasing? You look on the x axis. So from negative infinity, right? Because it starts from, it goes down forever it goes to the left forever. So from negative infinity, and then it stops increasing right here. All right, at this maximum here when x is equal to 2. So the interval of increase would be negative infinity. I'm going from the left to the right, and then when I get to 2, it stops increasing. But it's not increasing or decreasing at 2, so that'll be parentheses. And then decrease would be when it is going down, right? So decrease is this side as I go left to right. All right, and so again, we're looking at where it's decreasing. Well, it starts decreasing at 2 here, right? It picks up where this other one left off. At 2, it starts to decrease, and then it is decreasing forever to the right. Okay, it goes forever to the right, so that would be to positive infinity. So the left side is increasing, the right side is decreasing. And then I'm looking for the maxima or minima. Remember, maximum is the highest point. So that's this point right here, the highest point. And this would be an ordered pair. So I'm going to put an x coordinate, which would be 2, and a y coordinate, which would be 1. All right, over 2, up 1. That's how I get to this point right here. All right, now my x-intercepts are going to be where it crosses the x-axis. All right, the x-intercept is where it crosses the x-axis. So where does it cross the x-axis? Well, right here and right here. All right, the x-intercepts are on the x-axis. So that would be, and it's an ordered pair, so that would be, let's see, this guy is over 1 and up 0. And this guy is over 1, 2, 3 and up 0. All right, so for your x-intercept, you have an x value, but the y value is 0. Now my y-intercept is on the y-axis. All right, so that is right here. All right, here's my y-axis. So y-intercept, so that would be 0 for the x value. And then I go down 1, so it's negative 1 for the y value. All right, now zeros are the same as x-intercepts. All right, a 0 and an x-intercept, that's the same thing. So, but you write it as x equals, and you just put the x coordinate. So 1, 3, those are my zeros. And then now I've got my end behavior. So as x goes to positive infinity, what is happening to the function? So as x gets bigger, right, as I go to the right, what's happening to the function? Well, my function is going down, right? My function is going to negative infinity. As I go to the right, the function is going down, so it's headed towards negative infinity. And then this is as x approaches negative infinity. So as I go to the left, my function is going, again, the left side is also going down, all right? Both ends, it's called end behavior, so you look at the ends are going down, all right? So for end behavior, look at the ends, all right? And both ends are going down, so they're both negative infinity. And then we did that in class, and so now we're doing a little solving one here. So I've got an absolute value plus 8, so I want to get rid of that plus 8, so I'll minus 8 on both sides. And then I get the absolute value of x minus 4 is less than 4. Okay, so there's two ways you could do it. If it's a less than, you can put it in the nest. Negative 4 is less than x minus 4, which is less than 4. All right, and then you can solve it just by getting the x by itself. So negative 4 plus 4 is 0, is less than x, which is less than 4 plus 4 is 8. Okay, or you could do the flip-flop. All right, a lot of people like to do that because then you don't have to think about if it's less than or greater than. You just always do it the same. So you write it as two equations. So you would say x minus 4 is less than 4. All right, I just wrote it just like it is. Or x minus 4, and then you do your flip and flop, the opposite, minus 4. All right, so, and then you just solve. So I would do plus 4, plus 4. So that goes away, and I get x is less than 8, or plus 4, plus 4, x is greater than 0. All right, so either way, I have 8 and 0, and they're strictly less than, right? So that's an open circle. So there's 0, here's 8, and if I look at it this way, you can tell x is in the middle. So I'm going to shade, this is an and, right? And it has it shaded in the middle. If you look at it this way, you got x is less than 8, so you're shading this way, right, to the left. But you got to stop at 0 because x is greater than 0, so you shade to the right here. And this is kind of where they intersect, those two things. They overlap. How many values? Okay, well, if I divide by 4 to get the absolute value by itself, I get the absolute value plus 7. Normally, absolute value has 2 solutions, right? But 0, negative 0, and positive 0 are the same thing. All right, so there's only going to be one solution. All right, when I set it equal, when I set x plus 7 equal to negative 0 and x plus 7 equal to positive 0, well, that's the same thing. All right, so all you're solving is x plus 7 equals 0. All right, and so I would do minus 7, x equals negative 7. That is the one answer. And then this is saying what is not a solution of this guy. All right, so there's, you could solve it, or you could check each one, substitute in. So like for example, I could say 3 times negative 4 minus 6 is less than 18. And put that in Desmos and see what is, let's see, 3 times negative 4 is negative 12 minus 6, so that would be negative 18. The absolute value of negative 18 is 18. But is 18 less than 18? No. Oh, so that is not a solution. There you go. And then I could try, I hate questions that say not. That's okay, we'll do it. So that -4 is not a solution. And then what I could do is put in -5. So that's -15 minus 6, that's -21. The absolute value of -21 is +21. Is 21 less than 18? No. So that is not a solution. And then you could put in a 7. -21 minus 6 is 14. Is 14? Oh, yes, that is a solution. And then you could try 8. -24 minus 6 is 18, and then absolute value of 18 is 18, but 18 is not less than that, so that would be not a solution. And that is one way to do that. And then here, again, we're going to just solve this guy. So I'm not going to rewrite it. I'll just go ahead, and it might look messy, but this is what I'm going to do. I'm going to divide both sides by -3. So boom, that goes away, just because I have a small space here. And then I've got the absolute value of 2x plus 5. All that did is get rid of the -3. Now, if I divide by a negative, you got to do the flip, because this is going to be opposite. Negative divided by negative is going to be positive. So that would be a +5. And then now I got greater than, so I'm going to do my flip-flop. So I've got 2x plus 5, and I'm going to flip this and flop it. So I'll make that a -5. And then I'll just write it exactly the same, but without the absolute value. All right, and then we'll solve -5 minus 5. So I get 2x is less than -10. Divide by 2, divide by 2. So x is less than or equal to -5. So that would be a -5. And it's or equal to, so that's going to be solid, and less than is going that way. And then the other one, I'm going to have -5 minus 5. So I get 2x is greater than or equal to 0. Divide by 2, divide by 2. X is greater than or equal to 0. So it's greater than or equal to, so there's that, and then greater than goes to the right-hand side. All right, and so what this looks like as an interval would be, the red is going to be 0, but it's actually going to be a square one because it equals at 0 to positive infinity, right, union, and then the blue is going to be negative infinity. Oops, I really made that an 8 for some crazy reason. Negative infinity to -5, and it includes it, so I'll do the square bracket. So that's an interval. And basically set is these. If you are using the less than, set is where you have the less than or greater than. All right. And you would just say or. It's less than that or greater than that one. Okay, one more solving one. So again, we want the absolute value by itself. So I've got the absolute value here, so I'm going to -6 here, -6 here. That goes away, so I get the absolute value of x minus 12 is greater than -2. So do my two inequalities here, x minus 12, and I'm going to flip it and flop it. And then I've got x minus 12, and I'm going to flip it and, oh, no, I'm going to write this one the same. right? And then as I'm doing this, I'm noticing up here that I've got a positive number here and a negative number here for my absolute value. So absolute value is always positive, and positive is always more than a negative. All right, so I know that this is actually going to be all real numbers. And then interval-wise, that would be negative infinity to positive infinity. If you were to solve it, if you go ahead and add 10 to both sides, you'll see that it ends up shading everything in. So x is less than 12. And then if I do this, I'll add 12 here, add 12 here. And I get x is greater than 10. So that's like everything, right? Less than 12, that's going to shade to the left. And then greater than 10, that's going to shade to the right. So basically the whole number line is shaded. And so that's how you get all real numbers. But you can save yourself a little work if you realize it up here. Finding the inverse. Remember, you make this be a y, and the inverse is where your domain and range are switched. So I make the f of x be a y, and then I'm going to rewrite it as x equals 3y minus 8. See how the y turned into an x and the x turned into a y. Then I want to solve for y, so I'm going to add 8 to both sides, and I get x plus 8 equals 3y. Then I'm going to divide by 3 because I'm trying to get the y by itself. So I've got y equals, I'm going to go ahead and do like my symmetry property and just write the y on the left. And then you could write it as x plus 8 all over 3, all right? Or you could split it up and say, okay, y equals, this would be 1/3 x plus 8/3, right? Everything gets divided by the 3, all right? And then you could say the y is actually, go back to your f of x, and it's the inverse, so you put that little -1, and then you've got the 1/3 x plus 8/3. All right, so now it says, is this the inverse of that? All right. Well, let's go ahead and find the inverse of this guy. So I'm going to say this is y, and I'll say, well, there's two. Well, I think probably the easiest way is to find the inverse of g and see if it's equal to this. So I'm going to say x equals 4y minus 6, right? So because this was g of x, so I'm just going to make it be a y. And then now I'm going to make my y's into x's and my x into y. And then now I'm going to try to get my y by itself. So I'm going to add 6 to both sides. So it's looking like this might be it, right? So I get x plus 6 equals 4y. And I divide by 4. So I get y equals, so you see the 1/4 and you're like, oh, that must be it. But remember, you have to divide this too. So it's actually 1/4 x plus 6/4. All right, so they forgot to divide the 4 on both places. All right, so this would be no. And then here we're just writing the interval notation here. So I've got negative infinity to -7. So here's -7. And it's a solid circle because it's got the square bracket. And it's going from negative infinity, so it would look like that. And then the u, because I have another one here which starts at 0, but it's parentheses, so it's open circle at the 0. And I go forever to the right. And there's that. Okay, good job. Here we go. Now we're ready for quadratics. Hey, how you doing?
Alright, how are you?
I'm good. Your timing is perfect. I just finished a video. I was like, I did it last night, and it said the apex was off or something, and so it was just you couldn't see anything. I was like, oh my gosh.